thing that you have aldehyde comes out. For itself, it could be separated in two different scenarios, generally glyceraldehyde and through beta scission, hemolytic generate 2-uno-decanaldehyde, but the whole thing could also react with other fatty acid chain, could generate ketone and the alcohol. So, this is a whole process. Then, we haven't done it. What else we want to mention? It is very interesting. People find that for oleic acids, in the real life, we'll talk about is this ideal scenario, which is the model. But in the real life, it's not like that. So let's do this. I have oleic acids. Okay, so we can label 2, 3, 4, 5, 6. From this one here. 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17 goes up, 18. Double bonds is right here. That's oleic acids. But in the real life, I tell you, it's not going to be that simple. There are 4 different scenarios we'll generate. I'm only going to cut from here. Okay? What are the 4 different scenarios we'll generate? So we have 6, 7, 8, 9, 10, 11, 12, 13. The first scenario we created is a free radical right here. Okay. Then the second scenario will happen. Six, 7, 8, 9, 10, 11, 12, 13 is a free radical at position 11. These 2 are scenarios. However, how many percentage in a sunflower oil, if it goes through auto-oxidation, these 2 situations will happen? It is only 10%. But where are the 90%? It goes isomerization. Related to chain migration. So, what will be? This will look like this. It will happen at 9. So 6, 7, 8, 9. This comes out. And this chain goes here. So it becomes 10, 11, 12, and 13. What this means? That's trans. These 2 are cis. Okay, so is that going to be happening at 10? Yes, of course. So what is it going to be looks like? 6, 7, 8, 9, 10, 11, 12, 13. So if I have, will be like this. That's another trans. That's trans 1, that's trans 2. How many things will happen? How many percentage this one has? These two reactions. 90% almost. This means during the lipids auto-oxidation, not only we have aldehyde, ketone, and alcohol comes out, we also have trans fatty acids. Almost 90% of that bottle will be created. The trans fatty acids is very bad. It will not be easy to be hydrolyzed if you eat it with the liver. What this means? This means sunflower oil use a plastic bottle. The shelf life time is very limited. It is only going to be 1.5 years. And you should not buy a bottle if it's very close to the best buy sale time. Lots of the time, you go to the grocery store at Thanksgiving, Black Friday, they give you 3 bottles, only like $3, $5, but you look at the label, unless you do the barbecue, the whole group, like 100 people in your house to use it. The shelf life time is very short. But once it's oxidized, what happens? You have aldehyde, ketone, alcohol, and also huge amount of the trans fatty acids will be there. If they oxidized, those things will happen. The residue is trans fatty acids. So that is very interesting topic. Now we can give you the homework. So we say we generate a question. This chain migration, isomerization happened in the oleic acids. How about linolenic acids? It will happen too. And we have scenario 1, 2, 3, 4 happens. In the chemistry, we have a terminology, we call it resonance. So, if you want to do, we can briefly talk about, we don't have enough time, so we're going to just be brief. So, go here, 2, 3, 4, 5, 6, 7, 8, 9, go here, okay. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's too much. So this is go. Okay, what's going to happen? It's a very simple question. Let's say you're the teacher. In the linolenic acid, how many resonance will be created? First of all, will happen at the position 9. Okay, then what's going to happen? This is gone, goes here. Okay, second scenario, it will happen at the position 10. Where the double bond's gonna go? Goes here. It won't happen at 11 because that's called a meso intervention. It will happen at 11. It will happen at 12. So let's put these back. Not confuse you. Let's put these back. It could happen at 12. So if we have 12 happens, the chain goes here. That's also chance. It could happen at the 13. That's easy. Then it moves to here. So, 4 resonance will create it. Okay, now you are a teacher, you want to make it more complicated. How many in linolenic acid. Remember that cis9, cis12, cis15. How many? 6. Then you can ask the students to join. Is that right? That's a tricky question. But when linolenic acids, if it happens, that will have 6 different scenarios happen. This is also go back, you see sunflower oil. So linolenic acid is stereospecific at number 3 position. So I will tell you, that bottle looks terrible, I tell you. That bottle, there's lots of research data with a packaging machine. A packaging material, use glass bottles, use plastic bottles, use other material, then avoid to the light, exposed to the light, add metal ingredients, all kinds of things. Then you can do a running all kinds of the fatty acids profile, then you can see how many those chemical generated. You can have a good paper in the food chemistry journal. That's a high impact journal. That's what the paper can come out, and for good research, So that's something is interesting to know. These lipids oxidation is widely existing, not only for those 3 major aldehyde oil comes out, it also has a lot of the resonance oil comes out because of the chain migration and the isomerization. Typically, the trans will be generated. The last thing we also want to mention, once this happens, how do we know it's getting to like auto-oxidation? In the old time, lots of people testing peroxide. Well, peroxide itself is antimicrobial, so causes like oxidation of the bacterial cells. But they don't think it's a good one because the peroxide, only we know it's a progress. Does not mean the auto-oxidation really happens. So how do we know that? It's very simple. We want to test in the presence of CHO, which is aldehyde. But we're not going to usually directly to test the aldehyde. We will directly to test if this guy comes out. That's the simplest fatty acids. If this one comes out, then, which means 100%, the lipids oxidation is happening. Okay, so that's all we have today for the lipids oxidation. And I also have a slide to explain that. So Thursday, we have a slides. We're going to go over the lipids oxidation real quick. Then we're going to introduce you the texture analyzer. Then we're going to go to the lab. Because I'm spending $25,000 to buy the machine. I haven't seen how that guy goes. So we asked Ian to help. We're going to do a testing. And I also wanted to show you the water activity meter. There is a little bit tricky there to using. I will tell you the older methods when we use, and also some of the, you guys use a relatively rapid one, okay? So we're gonna do a little bit lab work demonstration on Thursday, okay?